Mutability of objects. Objects whose value can change are called mutable. For example, let's see a list. This list has right now 4 values. We are trying to print the ID or the unique identity of the list, followed by changing one of the contents at index 1 to 6.5 and then printing the ID of the list object. When we run the code, both the IDs are same. This means that changing of the values of the list object is possible and the ID does not change. And no new list is being created. So we can say that list, dictionary, set, byte array, user-defined classes as well as their objects are mutable. Similarly, the objects whose value cannot change are called immutable. For example, a string is taken, which is currently equal to a string quick fox. We are trying to print the ID, trying to change one of the contents at index 1 and then again trying to print the ID. When we run this, an error is thrown. This error is a type error which says that this object does not support item assignment. If we try to change the object itself, that is, first the string is equal to quick fox followed by the ID of that string, then we try to change the object to learners and try to print the ID of the string. In this case, it is possible. This is because we have changed the entire contents and an entirely new object is being created with 2 different IDs. So we can say integer, float, boolean, string, tuple are all immutable. Another important point to note is that immutable objects are more efficient than the mutable objects. The first is that working with immutable objects requires lesser memory. Here, let's try to create a list and a tuple. And for both of them, we are going to find out the size. So first, we have created a list having some values in the range 10,000 and then we have tried to convert this list into a tuple. For both, we are trying to find out the size. When we run this, the sizes are such that the tuple is much more efficient than the list as the size of the list is larger than the size of the tuple. So this is the first advantage. The second advantage is that the operations with tuples are faster than the operation with list. Let's try to time them. We are importing the timeIt module and then timing the same kind of function for a list and for a tuple. Here, when we run the code, as we can see, there is a huge vast difference in the time. The first one is the time taken by the tuple function and the second is the time taken by the list function. As you can compare that the first is 0.7 and the second is 0.9, which means that the operations with tuples are faster than the operations with list. The third is memory optimization. Let's see this code. When we attempt to create 2 immutable objects with the same content, that is 45, and bind them to 2 different names, which is A and B, the interpreter may choose to create only one instance and bind both the names to the same instance. As we can see over here that the IDs of A and B are exactly the same. Sometimes 2 different instances of immutable objects may also be created. This depends on the particular implementation of the Python language. For example, here A and B are referring to the same string quick fox jumps. When we try to print the IDs of both A and B, they are 2 different values.